welcome to the stage.
My name is Chiara from Promedital, a medical software house in Italy. In every CSD, the sterilization workflow that you can see here is a long sequence of steps. And even with well-designed sterilization workflows, there are recurring issues happening. We are going to focus on the packaging steps because we believe this is one of the most delicate steps of the entire process, relying strongly on the operator knowledge and expertise. The operator needs to check cleanliness, to verify functionality of the different instruments, to divide them by families, and at the end to reconstruct the tray following a checklist that may contain more than 100 instruments. And there is another crucial aspect related to the operational efficiency. Often there aren't standardized procedures. With packaging, there is no real-time validation. Once the packaging is completed, the tray, the container is sealed. You can't reopen it to check what's inside. So if an error occurred during the packaging, you will find out only in the OR when it's too late, when you may affect the safety of the patients or even the workload for the OR or for the sterilization center. The last crucial point is the economic impact. It takes a long time to train new personnel, and we have witnessed in all the facilities we work with a high staff turnover, and plus the packaging itself, it's a very lengthy procedure. Given this situation, our mission was clear. We asked ourselves, how can we improve this delicate step without slowing the operators down and without altering the workflow? We identified 3 key features that our smart workstation needed to have. First of all, we wanted our system to recognize instruments with extremely high accuracy, relying only on their shape, on their physical aspects, without using data matrix engravings or RFID tags. Secondly, we wanted to provide the operators with an intelligent guidance, especially to help them in case of uncertainties, in case of extremely similar instruments. And finally, we wanted our smart table to be seamlessly integrated in the workflow so that the operators can use it in a very natural way. So it needed to be ergonomic, easy to use, fast. To answer these questions, we designed this smart workstation. So it's a packaging table endowed with cameras, a light panel, a projector, and of course, an AI engine. The operator scans the code identifying a given clean set, performs a quality check of the instruments, and places them on the table with the only constraint of avoiding contact. After this, our system takes over. The cameras capture a picture of the entire table, and the AI algorithms recognize all the instruments at once, and the system provides immediately an answer to the operator, telling what's on the table, what's missing, and if there are instruments belonging to other sets. Simply a validation step that didn't exist before. After this, the system switches to the packaging mode. So using visual cues, that's why there is a projector, and vocal cues, the operator is guided in the correct reordering of the instruments inside the tray. So we make sure it is recomposed exactly as the surgeon or the CSSD manager have requested. How did we do this? So we proceeded almost simultaneously on 2 important fronts, the technical one and the operational one. So we needed to develop AI algorithms able to recognize instruments with high accuracy, but at the same time we needed to understand the real needs, the daily routines inside the CSSD. Let's start with the technical front. We identified 2 main challenges. First thing, high variability of instruments. The inventory is constantly evolving. There are always new instruments, new needs in hospitals. So a rigid AI model would not survive long. Second aspect, high similarity of instruments. There are instruments that may differ by only a few millimeters. This means that our AI model needs to be able to capture, to detect subtle visual differences that in certain cases even the human eye struggles to identify. So we developed a completely scalable and generalizable pipeline using the latest AI models, deep learning models. We improved, we optimized the data acquisition using the different cameras present on the table, and we have been able to shrink the number of photos needed for the initial training from more than 25 to fewer than 8. This approach, this new pipeline yielded several improvements. The accuracy of our system improves constantly without retraining it, just by using the system. And most importantly, this approach has allowed us to reach 99.5% accuracy. Let's move now to the operational front. We collaborated with several hospitals. Today, I will focus on a precise pilot project in an hospital in Modena. Its geographic proximity to our headquarters. In fact, this allowed us to collaborate with the CSSD operators on a daily basis and to improve the solution both on the software side and the hardware side. Let's explain a bit more about this pilot project. So it officially started November last year, and we worked with a team of 15 operators. Out of the 15 operators we worked with, only 4 of them were involved in the packaging phase. This is crucial for us because of the outcome of the project. During the first stage that ran from December till January 2025, we focused on collecting photos of instruments from different trays from all the specialties. Once we had a good data set to validate our system, we spent time with the operators in the CSSD to understand how we could improve it. So the first thing they told us was that the workstation needed to be more comfortable. And this is why we redesigned the smart table, allowing adding an adjustable touch screen instead of a fixed one, so that they could use it for the entire day. Also, we introduced a pack-based system that is extremely useful in reordering the instruments in the right way. And also, we added lots of customizable accessories that can be used for the packaging of the different types of trays. After this, they highlighted that the system needed to adapt to the different experience of the operators using it. And this is why we developed different collection modes, so that less experienced operator could take advantage of the use of the table, but experienced one wouldn't be slowed down by using the table. And also we introduced a training mode, so a modality to use the table during the training of the staff. Finally, we work on the accessibility. So for example, we added the audio guidance so that they can use the system even when their hands are busy. So they can use the system without looking at the screen, without touching the screen, but just being guided by the instructions provided by the system itself. Now we are approaching the last part of this presentation, results. To give you an idea of the results, I will describe the third ongoing stage of our pilot project in Modena. This is when we have started to measure the performances and to gather the final feedback of the users. However, before talking about quantitative results, I'd like to take a moment to read these statements from two of the main users of the hospital in Modena, because numbers are important. I'm a mathematician, but I think that the user experience, it's what really tells you if a solution can work in the real life. So Antonella, the CSSD coordinator, says the table pilot yielded very positive results, especially in terms of speeding up operations, enabling an increase in work volumes. Instead, Luana, senior nurse, says the smart table brought a tremendous improvement. We enhanced both accuracy and packaging times, significantly reducing human errors caused by oversight or visual mistakes. The smart table also supports training for new staff. These comments, of course, pleased us enormously. They are very positive, but I think they really touched all the main points that we wanted to achieve with our solution. In fact, let's now move to the quantitative results as well. This data is based on more than 2,800 packaging performed using the smart table. It's data collected till October 2025. To measure the impact of the table, we compared the average packaging time to start with of experienced operators packing without the AI table and with the AI table. The outcome was quite clear. In the graph here, you can see a comparison between the packaging of different categories of trays, from small trays on the left-hand side containing fewer than 10 instruments, all the way up to large trays containing more than 81 instruments. The yellow bar represents the average time spent by experienced operator working manually. The red bars represent the same operators working with the AI table. I think the pattern is unmistakable. The red bars are always shorter. And if you add up this saving in time for each packaging, and you consider all the packagings that are performed over 1 year, we are really talking about a huge saving of time. But this is not all, because it's not only about speed, it's speed with control. In fact, the other outstanding result that we experienced is that there was an important reduction of the incident reports from DOR per month. So before using the table, in this specific hospital, there was an average of 5 reports from DOR per month. After they started using the table, the number of reports dropped from 5 to 1, and I think this is absolutely massive. On the next slide, we focused instead on the less experienced operators. Only 4 of them were involved in the packaging. Today in Modena, everyone is able to pack a set. The entire team has acquired a huge flexibility. As you can see, in a very short time, here we are comparing inexperienced operators with experienced operators packing manually. In a very short time, they reached a similar speed to the time spent by experienced operators. In certain cases, for small, medium-sized trays, inexperienced operators can be even quicker than their experienced colleagues. I think this is empowering. And this result is possible also because of the support that the table provides during the training. In the graph here, you can see that from the very beginning, from the very first weeks of using the table with the training mode, the operators are able to pack a reasonable amount of time. So without the table, from our experience in different facilities, it may take from 3 to 6 months for an operator to become independent in the packaging. Using the table, in a couple of weeks, an operator can repack a set, and the smart table also gives feedback to the operator itself. So their performances are destined to improve. I have already mentioned some of the key aspects we are focusing on, and of course there are other little improvements like addition of LED indicator, lots of little things that are always meant to improve the usability of the software and the hardware as well. But I want to say that we are also committed to long-term sustainability. In fact, we soon will start to use it will be released a new version of the smart table without a projector, but with an integrated monitor embedded in the table itself. This will mean a more durable hardware, but also a better user experience, more feedback to the operator while they are using the table itself. And the second aspect is that we are also working on improving the energy consumption, optimizing the light panel that is part of the table itself. I really hope this presentation showed you how this AI table can enhance human expertise by supporting the operators in their daily activities and by making the packaging more robust and safer. Thank you for your attention.
Thank you so much, Chiara. That was a very fascinating conversation for a problem that a lot of our CSSD has. I'd like to hear as far as the new staff learning, reducing errors, and working on the throughput using technology. So thank you for that.